Hello everyone, my name is Daniel and I'm a programmer and an artist, and today we're going to be looking at how I made these rocks. Several months ago, I made a node group that was a rock generator. Whenever they first added the repeat zones to Blender, I was experimenting with those and seeing what you could do if you, in a repeat zone, remeshed and then displaced a surface several times to make a rock shape. And that had some interesting effects. And it was kind of cool. You could like model a shape. In the video I made like an arch shape and turn that into a rock. Anyway, recently there was a comment on that video asking if I would do an updated version of it with the new nodes that have been added since I made it and stuff like that. And I went back and was sort of looking through it, and I didn't see a whole lot that wasn't still applicable to Blender. I don't think many of the nodes I used have changed very much. But rocks are one of those things that are interesting. There's always another way to make a rock generator. So I thought that rather than trying to figure out what I could update about that one, I would just make a new rock generator that made a different kind of rock. I also realized that I used to make the node groups ahead of time and then just show a video walking through the finished graph. And then at some point I started doing more videos where I would make the node group and explain what I was doing as I went. And I'd be curious to know what you all think about those two different styles of videos. So I think videos that show the finished node graph are shorter and more concise and are perhaps more accurate, like you get straight to the point and don't make any mistakes. But on the other hand, you miss out seeing some of that process of how I got to the result because they might not remember all of those little steps. Anyway, so I'll probably continue making both, but I just thought it was interesting, so I'd be curious to know if anyone has any thoughts about it. All right, so let's get started here. I'm just going to go through the node group in this one. I'll go through it piece by piece and sort of show how I made it. And let's actually move some of these out of this collection and turn it off. And we'll use this object as an example. Now this rock generator is quite a bit different from the version I made previously. That one, you could actually model a shape, and then the finished rock would have roughly the same shape as whatever you modeled. This one, it's completely generated procedurally, and it makes a specific sort of layered, stacked layers style of rock. Obviously there's pros and cons to both. This one you can make lots of rocks that look similar really fast. You don't have to do any modeling. But on the other hand, you can't do any modeling, so you have less control over the exact shape of it. However, what I've done with this one is actually broken up the rock generation into steps, and I've applied the steps in a modifier stack rather than doing it all in one big modifier. So the advantage of that is you could come in here and replace this base mesh that's generated with some custom mesh, and then do all of the remeshing and displacement steps on top of it. Anyway, let's go ahead and get started going through the modifier stack. I'll turn everything off, and then I'm actually going to add this shape modifier, random shape modifier, so we can look at it first, because it's sort of the building block that the whole thing's built on top of. So I wanted a shape that was roughly flat on the top and bottom, and then went around in a sort of a circle or an oval shape, but that had variation to its profile going around. So the way I thought I would build that was just by initially making an ellipse, so rotating a vector around in a circle for all of the points, and then also shifting the position that I was rotating around from side to side as you did that. And then if for every point going around that circle or oval shape, you varied the distance that the point was placed away from the center it was rotating around, then you could create this sort of in and out pattern going around the oval shape. So that was the basic idea. The way that I did that is to start with a curved line. Let me make this a little bit bigger. So the curved line is just to create some geometry that we can have some points to work with. So then I want to resample that curve so that it has more points in it. So, because curved lines always just have 2 points, so we're going to resample it and add a bunch of points. How many points should we add? Well, that is actually going to be calculated by adding the radius and the stretch together, and then multiplying that by 2 times pi. And then if you divide that by some number, then that's going to be the approximate length of each edge in the curve going around the outside of the circle. So if you multiply the radius by 2 pi, that would be the circumference of a circle. Because I'm making the sort of ellipse shape, I just added the stretch value to it. That's probably not the accurate way to calculate the circumference of an ellipse, but it was close enough for what I was trying to do. So then that's going to give us a number of points, and we're going to resample the curve to that count of points. So now that we have a bunch of points, I want to set the position of those points, and that's going to create an outline shape like this. Now the way we're going to find those points is by using a bunch of math. So we're going to base everything off of the spline parameter factor of the curve. So that gives us a value that starts at 0 at one end and goes around the circle, or from one end of the curve to the other, starting at 0 and going up to 1. So then using that, we can add a random number to that value to make it a seed value, so that you could randomize this shape by changing that seed value. And then we're going to run the two of those combined into the W of a one-dimensional noise texture, which is just going to create a random value at every point, but not in a controlled random way. So if you have a value of 1 on one point on the curve, the very next point on the curve shouldn't be 0, because that would be too harsh of a change. It's too random. So it should more gradually shift between black and white. And we do that by a noise texture. And if you change the detail of the noise texture, you could control sort of how large or small those shapes were, theoretically. Then we're going to take that noise texture and we're going to use it to scale the radius. So the radius is the value that the user can input into the modifier to control how large the circle should be. And if we multiply the radius by this random noise texture value, then the radius varies between points on the curve, which is how we get the in and out from the center pattern. Then we're going to use that as the x value of a vector. And then we're going to rotate that vector around in a circle. So the way we're going to rotate the vector around in a circle is by using the vector rotate node. We're rotating around the z-axis, and we need an angle. We want that angle to start at 0 at one end of the curve and then be 360 degrees at the other end of the curve. So we can use that by multiplying the spline parameter factor again by 2 pi, which is in radians, 360 degrees. And then we can use that as the angle for the vector rotate node so that the points in the curve go all the way around in a circle. So if we plug that into the position and we turned off the noise, you can see we get a perfect circle. Then if we add the noise, we get a circle. The points go around in a circle, like the angle between points to the center is the same as for a circle, but the distance of the point from the center is random. And then I didn't want the shape to be perfectly square or circular, so I made it an ellipse. And the way you can do that is by, again, taking this spline parameter factor and multiplying it by 2 pi, so that it essentially goes from 0 to 360 degrees for the points around the curve. And then if you run that through the cosine node, you get a value that's positive on this half of the circle and negative on this half of the circle. And so then if you multiply that times this stretch value, you can control sort of the shape of the curve lengthwise. So then if you combine all of that together, the random value, the rotation around in a circle, and then the shifting side to side, depending on what part of the circle we're at, you get this random ellipse shape that we have here. Then I want to turn this into a mesh, so I'm actually going to delete the last point so that it creates a little gap right here. And then we're going to just fill the curve, because we know it's a single curve and it's flat, that's fine. And then I'm going to solidify it by extruding the mesh up. That creates a hole in the bottom, but we can flip the faces that we had originally and then join it all together. Then I added another little detail, which was just that you could stretch or change the slope of the shape. That breaks if you go too far, but you can sort of angle the walls in or out with that. And the way I'm doing that is by adding the normal multiplied times x and y, but not z. So it makes, so the normal of these points would be pointing sort of diagonally up like this. By removing the z component, it points flat like that. And then if you scale that by the slope amount, it pushes the points of the top of the wall or the cliff shape in or out along their flattened normal. Then there's a merge by distance, which logically would make more sense here probably. Doesn't really matter. And then that's just to connect the bottom face with the rest of this. And then just to, because we're making random nature shapes, add a little bit of noise to it to, vary the, primarily to break up the perfectly flat nature of the top. And that is a shape, random shape for making these cliffs. So then, if you have one of those, we could make a modifier that uses that random shape group we just looked at several times in a repeat zone to stack them on top of each other. So the way I'm doing that is by using a repeat zone. So the repeat zone, I don't think it actually needs any geometry coming into it because we're generating it all. But you do need a geometry socket, and it needs to go across to the other end because we're going to, every time we run an iteration of the repeat zone, we want to add the result that we created into a mesh that where we're combining everything together. So it starts with nothing, then after one iteration, we add a shape to it, and then after two, we'll add a second one. If you did it a third time, we would add a third one, etc. So then we want to know how many layers we want, or iterations, to run this for. So that's an input that's an integer. We're going to run the repeat zone that many times. Then we want to have an integer value that starts at 0, and we're going to add 1 to that every time, and then pass it back into the integer value. That's going to be the current index of the loop, how many times we've worked so far. So the first time we go through the loop, it'll be 0. The next time it'll be 1, etc. Then if we take that integer value and divide it by the number of layers, we can get a value that's sort of like a progress through the entire stack. So that will start at 0 on the first iteration, and then by the last iteration, it will be up to 1. Well, actually, on one additional iteration, it would be at 1. But so then, using that value, we're going to make a random shape, but I want to randomize the random shape every time. So that's what these random waves are for. They are one-dimensional noise textures, and we're just creating a random value to use as a seed. So we're adding that to the value that's used as the W of the noise texture, and that value is our divided index. So if you imagine our layers going up, stacking on top of each other like this, imagine a gradient going from black to white from the bottom to the top. That's what this value is, and then we're feeding that gradient value that increases from black to white with each additional layer that we stack into this random wave function. And what we're doing here is we're just adding a random offset to it so that for each different seed value of the random wave, we get a different part of this noise texture. And then once we sample that noise texture, we have a value that's somewhere between 0 and 1, and we're just going to map that to a range, whatever range we want this randomized value to be set to. So then all of these random wave functions have different seed values and different min and max values for the range of values they should generate, and they're just plugged into the radius, stretch, and height of the random shape, so that every time we iterate through our layers and add another layer on top, we get a different shape with a different radius and a different stretch and a different height, etc. So then there's a couple of additional things that I randomized using the random wave groups, and those are an offset for each layer and a rotation for each layer. So if I mute this add node, you can see that each layer shifts to the side a little bit. So what this random value is doing is just adding an X offset to every layer randomly. So in this case, because of the part of the curve we got, it's shaped sort of like this. So it pushes the middle ones further to the right. And that's just so that the stacks aren't perfectly straight. You get a little bit of a random shape to it. And then I also rotate each layer by a random amount. And that's done with this set position node here. It rotates each layer on the z-axis by a random amount. And that's again controlled by this random wave function. And you can also scale that in the setting. So that is all of the randomness for generating all of the different shapes. However, if we took out this here, we would see none of them are stacked on top of each other. So the other step is, how do we stack each of these layers we've generated so that they're on one on top of the other? And we can do that by using bounding boxes. So if we generate a shape and then we create a bounding box for it, then we have access to the Z position of the minimum side of the bounding box. So we can see in this case, this goes just below 0, so it's negative 0.07. Then if we have our input geometry, which is the geometry that we're adding, let's view the second one here. So we've generated one layer and we've passed that and joined it into our geometry. So then we're looping again. The geometry we just generated last time is already in there, so we can have that geometry and we can get a bounding box for it, which looks like this, and we can take the maximum Z value, which in this case is 0.48. So then if we subtract the minimum of the current layer from the maximum of the previous layers, we get the distance that we would need to move the current layer so that it would sit on top of all of the previous layers. So then from that value, I just subtract a amount that the user can specify, which is this overlap value. So if we set it to 0, we wouldn't subtract anything. Then we combine that into a vector. We want the Z component, and then we're just going to add that to the random offset and use that in a set position node. So if we disconnect this, we can see it's down here, and then once we add it, it moves up. And if we look at the result of that, you can see that some point of these will just barely touch the lowest point of the layer above. That obviously creates some gaps, which is why there's this overlap value, so that you can turn that up and squish them together a bit. And that's about it for creating this stack of shapes. There are other ways you could do this. Instead of generating them all randomly, one idea I had was you could actually just have a mesh that you had a bunch of points in, and you could just duplicate points around, and then on each point you could create a random shape. I thought that could be kind of interesting, because then you could like edit it. You could move these around to customize what the shape looked like, and that would be pretty easy to set up too. Just instead of doing the repeat zone, you would create one shape for each point. Anyway, then what I've done in the past, what I did in the previous video, is if you want to remesh this in geometry nodes, you can add it to volume node, and you can choose whatever resolution you want, and then you can do it to mesh, volume to mesh node, and you will get a remeshed version of whatever shape you had. And if you change the voxel amount to like something higher, you get a higher resolution one. It does have some weird effects sometimes, like these little isolated points that get left out. And I also think it's slower than using the remesh modifier. So in this case, I actually didn't do that. But if you wanted to do it all in geometry nodes, you could do mesh to volume, volume to mesh, and configure all of that in the node group. What I did instead was I just added the remesh modifier, and I feel like that gives slightly better results and is a little bit faster. So the biggest difference with that is that rather than being able to do everything in one node group, you sort of have to make this stack where each remesh step is another modifier. However, that also means you've sort of made a modular set of tools for making these rock things, which I don't think that's necessarily a bad thing either, although it does make all of the settings and everything it makes it a little harder to set up because you have to add so many different modifiers. Anyway, after remeshing, which joins everything together and gets rid of the layers in the middle, we still have the rough basic shape. We have a lot more topology to work with. Next, we want to displace it. So what we're going to do is 3 remesh steps. Each remesh step is higher resolution than the previous one. So we go 0.03, 0.015, which is twice the resolution, and then 0.01, which is slightly more. And then after each remesh step, we're going to just do a displacement, but I've made a custom displace modifier, so we have a little extra control over it. This displacement modifier does exactly what you might imagine. There's a noise texture in here, and then we're just going to offset the positions of the vertices in the mesh along their normal direction by some amount controlled by this noise texture. As far as additional features that I've added to this, there is a sides only option. So if you turn that off, then the top faces get displaced as well. If you turn it on, then the top of the mesh doesn't get moved so much, only the sides do. So if you turn sides only on, you're only affecting the sides. If it's off, you're affecting everything. So the way we build that mask is by taking the normal of the points of the mesh, and I actually blurred a little bit. That's not strictly necessary. You can see it doesn't make like a huge difference, but it does soften out some of the fine details a little bit, especially that's more useful later after we've done some displacement, I think. Anyway, I'd recommend blurring it a couple times just so that everything's averaged out a little bit more. Then if you take the dot product of that with 1 on the z-axis, you get all the faces that are pointing up. If we take the absolute value of that, we can get 1 at the top and 1 also at the bottom. And then if we just map the range of that to be between 0.3 and 0.9, I'm crushing the value slightly so that there's a portion of the mesh that's all black and a portion of the mesh that's all white. And then I'm also I'm inverting the result so that the sides become white rather than the top. And then once I have that, I blur that mask by 1, which just softens the edge a little bit. And then if we add a tiny bit to that, if we add 0.1 to it, we'll have our displacement affect the top by 1/10 of what it affects the sides. And then we're just scaling the normal and running that into a switch node with our sides option. And if we turn sides off, then we just use the blurred normal instead. This is going to be the vector that we use for our displacement. That's the direction we're going to offset the points. So if we were to view that, the arrows on the sides are longer and everything points outward. Then once we have that direction vector that we're going to move our vertices in, we need to decide how far we want to move them. So we're going to scale that vector again, and this time we're going to scale it by our height map, which is a noise texture, and then I've exposed some options like the scale and done some other things to control it. So the first one is there's this option for the direction, so it can either be even, which makes these sort of even shapes. They're not longer or taller. Or you can do vertical shapes, which looks like this, or you can do horizontal shapes, which looks like that. And the way I'm doing that is just by taking the position, I'm multiplying it by 0.1 on, for even, I just plug the position straight into that menu switch. For the vertical, we're multiplying the z-axis by 0.1, which stretches the texture vertically. And for horizontal, I'm multiplying x and y by 0.1, which stretches the texture horizontally. Then once we do that, I'm plugging the result of the switch node, whatever scaled position we decided we wanted from the menu, into a vector rotate node, and I'm just rotating the texture slightly, randomized by the seed value. That's probably not strictly necessary. And then I'm also, in the seed value, creating another random integer that's just between 0 and 100,000, and I'm using that as a z offset for the position that we plug into the noise texture. So that means that every time you add this displace node, if you change the seed, you get a different part of the noise texture. So for example, if we were to multiply this displace texture, that would look kind of bad because it's essentially the same as multiplying the effect times 2. But if we were to change the seed, you would get the same pattern of noise, but a different variation of it because we've moved a different part of the noise texture. Then once we have our noise texture, it looks like this. And again, we can change the style of that by adjusting the direction. Then I wanted to create a couple of different patterns for how you could adjust that noise texture. So the first one would be none, you don't adjust it at all. Then I made this one, which is high contrast, so it crushes the values more to the center. So it's more likely to be black or more likely to be white than some gray value in the middle. That's this curve here. And then I also made this one here, which was just to create less big changes and more small changes. So it just zigzags up and down between 0.75 and 0.25. So it's a subtler adjustment, but like higher frequency. You could add more of those if you had other ideas. Like you could add another one and we could get rid of these points and do one that was like this and call it we could add another option to the menu switch and call it inverse. So then you could flip the noise texture around backwards, which would look like this. So anyway, that was just so that I could reuse the same displace node multiple times and change how it affected things slightly. Once you have that value, I subtract an amount from it, the mid-level. So that's just so that you can control if the displacement cuts into the mesh or extrudes out away from the mesh, how much it does both of those. So if you set it to 0.5, theoretically it should do half in, half out. If you set it to 0, it would be all out. And if you set it to 1, it would be all in. So 0.5 should be the middle ground, but typically I find 0.5 actually creates some problems especially on sharper corners like this. So I found like 0.3 something, 0.35, something like that actually worked better. So it's a little bit more out than it is in. And that way the sort of the corners of the cliffs didn't get crushed together quite so much. So that's the displace node. So then all I did was I stacked 3 of those displace nodes on top of each other. And between each displace node, I remeshed the result because if you look at the wireframe here, you can see that, say on this corner here, this face got stretched quite a bit. It's a lot bigger than it was before we did the displace. It's almost twice as big actually. And so if you displaced again without remeshing, if you displace too many times before you remesh, you start to get really stretched polygons or squished. You can see like in here, it's really squished this together by intersecting in a weird way. So if you remesh it, that fixes all of those problems. You can also bump the resolution up to be higher than it was before to add finer details. So let's turn this wireframe off again. So for the second displace, I again did only the sides. I did the strength quite a bit less. So this is a finer detail. And this one I did even direction, but the wave pattern. And that was just to vary the shapes a bit. If you wanted to try something different, we could do vertical. See what that looked like. That creates sort of a weird grid pattern though. And then we can do high contrast. Get a different sort of style. And then we could change the seed to get a different pattern. If you wanted to, you could just sort of click through these until you found one that you really liked. And then once we have that, I'm going to remesh again. Every time you remesh, it gets slower and slower. The viewport doesn't really get slower, but the processing and changes gets a lot slower. We're just going to do one final displace, and this one we're going to do across the entire mesh. So sides only is off. The strength is very low. And then once we have that, this is the final mesh. If you're actually going to use this in a game or something, you would need to remesh it and bake the details onto it. If you're just going to render it, it actually renders fairly quickly. So then as a final step, I have this modifier shader attributes, and all it does is it captures some information to use in the shader and also sets the material to this rock material. Anyway, what I'm capturing for the shader is the signed angle of the edges evaluated on the edge domain, but captured on the points. And then I'm blurring that attribute and also capturing that. So I'm going to use the blurred version as a mix factor for a mix node to mix some colors together as a sort of a base layer for the color. And then the sharper version is used to overlay these sort of whiter detail bits in the dark crevices. Then I'm storing the dot product for the normal blurred again, just to smooth things out a bit with 1 on the z-axis. I'm actually using that to control the displacement of the... So there's some added detail here from a normal map texture, and I'm using this dot product to control the strength of that. The reason I captured it as an attribute is because if you use the normal from the shader, it was creating weird artifacts for me. And then finally, I'm taking the geometry and I'm adding just a tiny bit. I'm just moving the source position up a tiny bit and doing a ray cast up. So we're going to look from here up and see if we hit anything. And if we hit anything in 1 meter, I'm just storing the inverse of that as a mask. So this shows us all of the parts of the mesh that aren't covered by an overhang. So then if we look at the shader, it's just a bunch of mixed nodes. So this was I'm taking the Z position of the mesh and mixing it together to create this stripe effect. And I'm rotating each of those positions. I'm rotating the position by just a little bit so it's not perfectly straight up and down. I'm doing 2 of them, and then I'm taking the Z position. I'm doing a modulo on it so that it repeats, and then dividing that so that each repeat goes between 0 and 1, and then I'm running that through a float curve to create this striped pattern. There's probably other ways to do that, but then I'm multiplying them together to create a more random striped pattern, and then I'm using that as an overlay on these colors. These colors are from the blurred edge corners, which looks like this. I'm multiplying that by -2 so that I get the inverse of it, and then I'm using that to mix this purple color into the cracks, and then I'm overlaying that striped pattern on it. Then I'm taking the original blurred edge attribute, and I'm mixing the results of the crevices version of it into a light color to get this sort of effect. This is the base color map. Then I'm taking the edge attribute, not blurred, which is much noisier, and I'm using it for a soft light to add additional detail. So this is the blurred version, the base color, and then with the soft light edge. Then I'm also taking the original blurred base color and running it through a hue saturation value node to create this more yellow version for the top and also a dark version for the bottom. So then I'm taking the overhangs mask. So I'm taking the normal, doing a dot product with Z and crushing the blacks a bit so that it's more just the top. And then I'm multiplying that times that overhang value so that we get rid of the details under the overhangs. And I'm using that as a mix factor to mix between our base color and our lighter, this yellow variation of it. So that gives us this, where we have the yellow on the top and the red on the sides. And then I'm doing the same, but with the dot product looking down, -1 on the Z-axis. And I'm using that as a mix factor for this result and this darker color. So then we get the darker color on the bottoms. And then the only other thing I'm doing is I'm taking the object coordinates and multiplying those to run into a noise texture. So the reason to multiply it is just to make it more stretched like this. And I'm using that as the height in a bump map. And I'm using that dot attribute through a map range node to control the strength of the bump. So the bump is stronger on the sides and less strong on the top. And that gives us this result here. If we can see that without the normal map, looks like this, and with the normal map, looks like that. So anyway, that was another way. There's probably infinite different ways you could make rock generators, but this was another way that I've come up with. I think it works pretty well, makes some interesting sort of patterns. And like I said, you could customize it and change how you generated the base shape to be something different to have more control over making your own shapes. You could, like I said, you could use points to create these shapes instead of automatically stacking them, or you can just model your own base shape and then have it add the details. So anyway, hopefully that was interesting. I have put this file up online with this rock generator if you'd like to download it and play around with it or make modifications to it. You're welcome to do that. If you have any questions, feel free to ask. I also have a Discord server. You're welcome to join that. If you're interested in finding out more about me and the things that I've made, check out my website. There's a link for that in the description. Links for everything's in the description. Yeah, that's all I've got for this one. Thanks for watching.